Meselson Stahl video presentation by Celine Young, Celine Chi, Harrison Walker, and Mitchell Toohey. So predictions of DNA replication. So the Meselson Stahl experiment was an experiment that was designed in order to see how DNA would replicate, and there was three predicted outcomes, which was conservative replication, semi-conservative replication, and dispersive replication. So we will first start with dispersive replication, which is DNA replication will result in two DNA molecules that are hybrids of the parental and daughter DNA. Each strand of DNA has patches of the original and new DNA. And as the replication cycle continues, the amount of parental DNA in the daughter strands decreases over time.
So, in conservative replication, the first DNA replication results in one identical strand, which is this pink one, and one new strand of DNA, which is this blue one. And then in the second replication, the new strand would replicate into two new strands, and the identical strand would replicate into one identical strand and one new strand. So by the end of the second replication, you would have three new DNA strands and one identical to the parent.
Next up, we have the semi-conservative model. So first, in the zero generation, two strands of DNA unwind from one another. Those two strands come from the parent here, which are both represented by pink. Next, each parent strand acts as a template for the daughter strand. The daughter strand is represented by this blue one here, and the parental one, again, is pink. So we see that this results in two new DNA molecules with one new strand and one original strand. In this in the next generation, then we see that as this replication cycle continues, then the parental DNA still stays in the DNA population, but we see a greater dominance of this newer strand. So, which one's actually right? So, the Mendel-Stahl experiment proved that the semi-conservative model is actually correct, in that they were able to see that each daughter has one old and one new strand.
So the goal of the Meselson Stahl experiment was to prove which of these models was correct, and semi-conservative was proven through this experiment, where E. coli bacteria was put into N15, a heavy isotope of nitrogen, and the molecules in the cell that contained nitrogen became heavy, creating a biological molecule such as DNA. And then the same bacteria was then switched to a medium of N14, which is a lighter isotope of nitrogen, and then the DNA was then measured. The density of it was measured through centrifugation, and over time we saw less and less N15 density as no more E. coli was being grown in the N15 medium. So, what were the results of the experiment? So, in generation 0, E. coli was grown in an N15 medium, resulting in bacteria with DNA that was heavy. As we can see here, both these bands are darker as they're denser. And then the bacteria was transferred to a medium containing light nitrogen, and the replication was allowed to continue, seeing in generation 2 how there is a hybrid of both light and dark DNA. And then the DNA was extracted and centrifuged, which showed the separate densities by two distinct bands. And the intermediate band it showed that the DNA molecules made in the first round of replication was a hybrid of light and heavy DNA, rejecting the conservative model. And we were also able to reject the dispersive model because there would have been double-stranded DNA with both strands having mixtures of N15 and N14. However, we can see that they are completely separate strands. As more replications occurred, there were more fainter bands, showing that there was less and less percentage of N15 as no more was being injected in, and this indicated that DNA replicated semi-conservatively, where each strand of DNA serves as a template for synthesis of a new strand. Thank you.